Okay, so to continue where we left off, let's switch rectangular points, meaning going left, right, up, and down, into polar. There's still 4 very important equations from that last video that you need to know. I don't know if I have room to write them all up here, but mainly x squared plus y squared equals r squared, and the tangent of theta equals y over x. Like I said, these should be familiar to you from vectors because they're exactly the same formula as vectors. So these are the 2 main ones you're going to use to go from rectangular over to polar. So for polar, we need an r and we need a theta. So first, for this one, we will do 3 squared to 3 squared plus negative 3 squared equals r squared. So 3 square root of 3 squared is 9 times 3, or 27. I gotta erase that. Drives me crazy when it does that. 27. Negative 3 squared is 9, equals r squared. So r squared equals 36. So r is 6. Now technically r could be plus or minus 6, but usually we try to keep our radius as a positive number when we're doing these, and our angle as a number between 0 and 2 pi. So there's our r. In order to find the theta, we're going to use tangent. So tangent of theta is equal to negative 3 over 3 square root of 3. Tangent of theta equals negative 1 over the square root of 3, or square root of 3 over 3, negative. We need to decide which angle that is. So if you could see my hands right now, I'd be doing the hand jive and figuring out that that is some reference angle of pi over 6, but we need to figure out which quadrant we're in. If you actually were to graph this point would be in the 4th quadrant. I have to erase that again. There we go. Let's try that again. Over to the right and then down, it would be over here somewhere. So we need a 4th quadrant pi over, what did I say, 6? Pi over 6 angle. So that would be 11 pi over 6. So our ordered pair for this one would be 6, 11 pi over 6. The next one, same idea. We would do negative square root of 6 squared plus negative square root of 2 squared equals r squared. So we'd have 6 plus 2 equals r squared. R squared would equal 8. So r would equal square root 2 square root of 2. To find our theta, we would do tangent of theta equals negative square root 2 over negative square root 6, which is 1 over square root of 3. This point is in the 3rd quadrant. Oh no, it's not going to like that. So we need an angle in the 3rd quadrant of pi over 6, and that would be 7 pi over 6. So this answer would be 2 square root of 2, 7 pi over 6. Okay, moving on. We are also going to change equations from rectangular to polar, polar to rectangular. So these are rectangular equations. The reason I know that is they have x's and y's, and we want to change them into polars. So we are going to use those same 2 equations that we used before. X equals r cosine theta, y equals r sine theta. We can also use x squared plus y squared equals r squared. And let's see, where else can I write this? Tangent of theta equals y over x. So, for example, the first one where it says x squared plus y squared equals 9, we could change x into r cosine theta. We could change y into r sine theta. But then I should back up a step. Our goal is to get these into the equation r equals everything else. If I have r squared cosine theta squared plus r squared sine squared theta equals 9, that's a lot of trying to get r's all by themselves and a lot of stuff going on. So I would suggest using the x squared plus y squared. This is equal to r squared. It doesn't mean we have to have r's and thetas. Our goal is to get rid of x's and y's and put our entire equation into r's and thetas. This one is equal to r over 3. To just give you an idea of what's coming ahead, we're going to be graphing these. This first equation is a circle centered at the origin with a radius of 3. And if r is equal to 3, that means every angle, no matter what it is, with a radius, not radius, with an r of 3. So 1, 2, 3 going around like this. Both of these would mean the same thing. That's not too bad of a circle, considering I drew my axis first. So r equals 3 is an example of a circle in polar form. So now we have this y equals 5. I would not try to use x's of anything, so I would use the r sine theta. R sine theta equals 5. Gotta erase that. Our goal is to try as much as possible to get them solved for r. I haven't 100% looked at all of the answers in the back of your book, but most of them try to get it solved for r, which means I would divide both sides by sine theta, but when sine theta is in the bottom, that is really cosecant. So y equals 5 is equal to r equals 5 cosecant of theta. The reason that both of these numbering graphing systems apply is because some things are easier to graph in rectangular form, like y equals 5 is a much easier equation to graph. But in polar form, r equals 3 as a circle is much easier to graph. So polars have benefits over lines, but this one would be much easier to graph in rectangular mode. Okay, going the other way, there's two main things that would be important in how to solve these. We're still going to use those same 4 equations that we've used before, but a few couple things that are little tricks in order to do these. The first one is to multiply both sides by r. And the second one is to square both sides. These two tricks kind of help you get everything where you want it to be. So the first equation says r equals 4 sine theta. Well, if I square both sides, that gets me r squared on the left-hand side, which is good, which then I can change that into x squared plus y squared. But on the right-hand side, if I square that, I get 16 sine squared theta, and that doesn't really help me get rid of everything. However, if I multiply both sides by r, I get r squared equals 4r sine theta. So by multiplying both sides of the equation by r, I've fixed the left-hand side, so that could be x squared plus y squared. But I've also changed this so that could be 4, and then this part can be y. I've actually fixed both of the issues. Since we've done this in the past, and it's a good point to review, when I have x squared plus y squared equals something, that is a circle. And when we get into graphing these, you're going to learn that that is also a circle. So you should solve this like it was a circle. X squared plus y squared minus 4y plus blank, like completing the square, equals 0 plus blank. Divide 4 in half and square it, and you get 4. Put that over there as well. So you get x squared plus y minus 2 squared equals 4. So that would be your equation. In terms of converting these equations, I probably won't be using Delta Math for this because your answers can look kind of different. If it is something that you know, like a circle, you should put it in circle form. If it's something like a line, you should put it in y equals form. But like, for example, the next one is something called limnason, and it's not something that you would know in rectangular. So once you get rid of the r's and thetas and you replace everything with x's and y's, you can be done, and the answers may look different depending on which one you go with. So I am going to multiply both sides by r to begin with. So I get the same thing as I did on the last one. R squared equals 5r plus 4r cosine theta. Well, r squared is equal to x squared plus y squared. I'm going to leave that 5r alone for a minute and then change that to plus 4x. let's see. At this point, we still have to get rid of that r. And I would really like to get it into r squared. So I'm going to move that 4x to the other side. And I'm going to make that 5r. Then I'm going to square both sides. Hope you're enjoying my straight lines that drive me crazy. X squared minus 4x plus y squared squared equals 25r squared. And now r squared can change into x squared minus 4x plus y squared squared equals, this 25 can either be on the other side or this side, x squared plus y squared. This is really, there's no nice, pretty rectangular format for this equation. So there's a lot of different ways you can write your answers, but this would be probably the simplest, maybe moving the 25 over to the other side. It doesn't really matter where that 25 is at. That's what I was saying before. When we graph these, this first one, r equals 5 plus 4 cosine theta, is a really nice, pretty graph when we do it in terms of polar. But if we were to try to write that same equation in rectangular equations, it gets ugly and we wouldn't even have an idea of where to start, which is why they created polars in the first place. And well, moving forward, yeah, we'll get into that in the next video. So I think that's the last slide. Let's see. Yep, it is. If you have any questions, feel free to ask Google Classroom. Otherwise, that is it.